Let's take a look at Localnet. Localnet is ZetaChain's development environment where on your local machine you start an EVM chain and Localnet installs gateway contracts, essentially all the wiring necessary for you to experiment with universal apps. So it's all running on your machine and it lets you iterate quickly and develop universal apps much faster. So let's take a look and use example contracts for that. If you have a macOS or Unix machine, just open a terminal, type git clone, and clone the example contracts. Once it's done, you can take a look. In the examples directory, we have two example universal apps. One is a simple hello world, and this is one we're going to be taking a look at today. It's a very simple application. It basically implements a single function called onCrossChain call, which accepts calls from connected blockchains, and it emits an event with the value that is passed from a connected chain. So if you are calling this contract from Ethereum and you're passing a string foo, then it will emit an event with the string foo. So this contract is deployed on ZetaChain, and we will be calling this contract from connected chains. So let's take a look on how you can start Localnet first. So go into examples, hello, and if you type npx hardhat, before that don't forget to run yarn to install all dependencies. Type npx hardhat and you'll see all the commands that are available, and one of them is Localnet. Localnet is loaded from npm package called ZetaChain Localnet. You can install it manually, but it's already pre-installed in examples. If you type npx hardhat localnet, it will start an Foundry Anvil blockchain and deploy all necessary protocol contracts. You can see the output, blocks being generated, and all the protocol contract addresses. Now let's compile and deploy the hello contract in a separate terminal window. npx hardhat compile force, just to ensure that it compiles the latest version. And we can now run deploy. Make sure to specify localhost as the network, and you can see that the contract has been deployed. Next, what we can do is we will actually interact with this contract. The way we're going to do it is through hardhat as well, just to make it a bit easier. So you can see that there are some tasks here that can help us interact with a universal app. One of them is EVM call, so there are tasks that call from EVM chains like Ethereum to ZetaChain, EVM call, EVM deposit, and deposit on call, as well as functions for calling from ZetaChain to connected chains. So we're going to be using EVM call. EVM call essentially expects just the receiver address as well as types and values. So for our receiver address, we're going to be using the address we got from the terminal window. So receiver, and we need to specify types. So our contract is a very simple one. It just expects to get a name in a message. So as a type, we will specify basically what you pass to ABI encode that would be a string, and the value is going to be Alice. Network localhost. I made a mistake in the types. You can fix that by just using different code. Okay, so what happens here is a lot of things actually happened. So we first made a transaction on EVM chain, and we made a call to the gateway contract on the EVM chain. We can see that the gateway has emitted a called event. The ZetaChain protocol contracts recognized this event, and the ZetaChain protocol essentially called a universal contract. So now we can see all the values that were passed. So ZRC20 represents the gas token of the chain from which the call was made. The message should contain the message that we passed. This should be Alice. And chain ID is 1. And now we can see the event emitted from on-cross-chain call. That's how we know the call has been executed successfully. So even though this is running all on the same local chain, we can see the gateway contracts in action, where we called EVM gateway, and the ZetaChain protocol essentially simulated a call to a universal contract, and this on cross-chain call function got executed, and we saw an event. Okay, so what we can do next is stop localnet, and let's introduce an error here. All right, let's make our contract revert on purpose. Now we need to recompile it again. Start localnet. I always like to start localnet fresh just to ensure that the addresses are the same, and there's no extra state to worry about. So it's always easy, it's very fast, so there's no reason why you wouldn't want to restart it, probably. So next what we're going to do is deploy the contract. And as you can see, the address is the same. So what we can do next is call the contract. So just checking that the address is the same, we pass Alice, and we're broadcasting this to localhost. So what happens here is interesting, right? The gateway emitted a call event, the universal contract was called, but then we see an error during the execution, which is expected, right? Because we inserted a revert. And what happened next is the ZetaChain protocol essentially tried to revert the transaction, right? Because it encountered an error during execution, and but it doesn't know what to do next because we didn't pass the instructions on how to handle a revert. So it essentially TX reverted without a call. So this is not great because most likely you want to handle situations where your contract reverts, right? The way we are going to do this is through another contract. We just call it revert, and it's a super simple contract. So hello contract is deployed on ZetaChain, and revert is deployed on an EVM chain like Ethereum. Again, this is all running on the same chain, but you can imagine that those are two separate chains. So revert, we've already compiled it. We just need to deploy it as well. So the only function that we're really interested in is this on revert, right? This is a special function that gets called whenever a contract is reverted. So now we're going to use the same well, first of all, let's deploy. We have a task called deploy revert. And now we can run EVM call again with the same receiver, except now we will specify revert address, which is which contract will be called on the source chain if the original call throws an error. So revert address is our revert contract address, and we'll also specify call on revert to tell the gateway that we actually want to make a contract call in case the original call reverts. So now let's make this call again. And now what we see is something else, right? The gateway called event is emitted, the universal contract is called, it throws an error, which is expected because we have a revert. And now the revert contract gets executed, and we can see that it was successfully called, and we also see an event from this contract. So this is how you can quickly iterate on universal apps, and hopefully this was helpful to understand how you can use Gateway to call universal apps and how you can use the Revert Handling system to actually call a contract in case something goes wrong. So you can imagine that this can be used, for example, if you're transferring NFTs, you would lock your NFT when you transfer it, and if the transaction reverts, then you can unlock it back.